Hello and welcome to a new episode from Just Enough series. And in this episode, we'll speak about monorepos. What is monorepo? Why it is being used? Why companies require it? Why a company like Google is actually using the whole idea of monorepo. So we'll discuss all these concepts, and we will discuss one of the tools that helps to manage monorepos, and it's called Lerna. Although it's a little bit old, or they say like it's not maintained, the main concepts behind Lerna are still valid, and they exist in other tools as well. We will mention them in this video, but the whole general idea of this series is to give you concepts over tools, so you're able to change tools whenever you would like, but the concept is still valid and still the same. And I would leave also a link after like recording this video, which would have all the concepts that you would need, and also the example code that you would need to use inside this inside this tutorial, so you would have everything to start practicing and learning all of these concepts. Yep. So without further ado, let's start with discussing what is monorepo. And I would prefer, before starting discussing monorepo, maybe stating what is the problem statement. Why do we need or needed the idea of monorepo? So when you start developing any application at first, you would usually start with like a directory where you would have like everything under your application, and you would have like maybe the source directory when you start the application, and under it you would have components, you would have containers, you would have maybe libraries, you would have like different things, and you would have like your JS file, maybe your TS file, maybe you would have like styles, and under this one you would have your CSS files. So this is usually how we structure our application. This is how you start an application. Like for example, you joined a company and then they told you, okay, let's start like an invoices application because you would like to do like invoicing. So probably before this one, you would have like inside your containers, you would have the login, you would have maybe the logout, maybe inside the library, you would have your session management and all of this stuff, but everything would be under a single directory or a single folder. So all of this is fine. And of course, like we didn't mention the package.json because this one is also important. So as an example, if we go to another concrete one, for example, this is one of the applications that I have built. You would see like we have the source file. Under it, you would have like components, containers, we'd have store, utils, like your, this is a React application. You would have links for everything related to the application. So everything is under a single directory. Any project you would go to another project as well, you would see also source and you would see whole application. But at a certain point, this application starts to get a little bit bigger. For example, you could imagine if we build a source directory for Amazon, for example, or I wouldn't say Google, of course, like Google also could be Facebook, or any big application, you would have a huge database and you would have everything under it. So it's quite enormous to have everything under source, and it would be heavy to manage. For example, you would have, okay, we don't know, there is a store that manages the session, or there is a file that manages the UI, or where is the component. So it's everything is out of control basically because it's huge. And that's why they say, okay, let's cancel all this thing, and we don't have what we call now, this is a monolith, and monolith means everything under a single directory. The whole application is under a single directory, everything under a single place, and there is no separation between them. So any file could call any file basically. So this is, of course, like this is good because it helps us when we start the application. It could reach the market easier, and we could sell faster, and we could get feedback from customers. So it's great at first, of course. So monolith is not bad. Monolith is great when you start the application. But when the application grows, we will start to say, okay, let's start what we call now microservices. And of course, you would be aware of this one. And microservice in this case would say, okay, let's separate, for example, our invoices application. Let's separate maybe reports to be an application. And let's separate, I don't know, like invoices, because of course like it also have invoices inside this one. Maybe we would also separate PDF. Maybe we need this one, maybe we need another one for Drive, and so on. Like you get the whole idea. So each one will separate each one of them into their own separate repository, and each one would have package.json, and we would have inside each would have like package.json related to this one, and of course like I wouldn't write it. Yeah, so every one of them would be an application, and each one of these would be managed by a separate team. So this is the whole idea. Separation helps with divide and conquer basically, and each team, you would know, like it has like 5 to 8 developers. And in this case it would help us to manage. So one team would hold this one team would hold this one team would hold this one. So everything is great at this point. So we are able to scale eventually the whole application. In front end, it might be not related to scaling only, because dividing as well helps us with reducing the bundle size. So you could imagine with the previous example with the monolith, everything may be under app.js, or another thing you would say, okay, maybe we could use webpack, and with webpack we could divide the application into separate JS files. Yeah, it's also valid. I wouldn't say it is not valid, but you could imagine it changing one file in a single place, and you would have to build the whole application. So you just like change it one comment, and instead of this place is just, I don't know, like maybe it's just like a commit that you change it. You would think, okay, it doesn't need to run every test, it doesn't need to run everything, it should only run at this place or this comment, and in this case it should take like 1-2 minutes. But rather, because this is a monolith, everything runs, so it would take a huge amount of time to run all of this. But with microservices, of course, like I would just like change this one, so it's a little bit smaller and I don't care about the others. So that's why we go to microservices. But everything is not nice. We need to say that but here. So with microservices comes another problem, and this problem would be inconsistency. And this problem doesn't exist with monoliths. For example, in monoliths, you would have a single ESLint rules, and you would have a single prettier rules, and you would have another like tsconfig rules. Whatever tooling you are using inside, you would have a single file for this one. But with microservices, each one of them would have their tsconfig in this case. So each one would have their tsconfig, they would have like their ESLint, their prettier, so each one would be separated. So one team would say, okay, maybe we would like to use double quotes. Another team would say single quotes. So you might think, okay, this is a small thing, but another problem might be functions, maybe debugging. This also worsen when one developer would like to go from our search like team A to team B, and they are using in team A like certain tools, and when they go to team B like another tools. So it increases the time of onboarding of developers. And with this inconsistency, maybe one team is using a tool different than the other. So you would say, okay, it might get a little bit messy. It doesn't exist maybe with small teams, but when teams get larger, it would be a lot of messy problem. We didn't also speak about including a UI library. So if you have like usually inside each company, they would have their own UI libraries that they are using. Not only like you would say, okay, material UI, but most companies would have material UI, they would have another UI library built over it, because they have, of course, like custom components and so on. So if this one is a separate repository, and this is one of the famous examples, if this one is a separate repository, in this case, each, like when we get like change maybe the colors or add an extra component, we would have to upgrade from version 1 to version maybe like 1.2 and so on. Each one of these application would have to upgrade, and this is a huge amount of time. This problem didn't exist with the monoliths, because everything I was just like change the button inside one of these file, and it was just like affect each one of these like directly. But with microservices, yeah, I have to upgrade this one. So you get the idea. So there is inconsistency in this case, and it would be hard to like maintain dependencies among teams. Of course, not just a UI library. Maybe it's also like an API library that is being maintained between backend and front end. So all of this takes a huge amount of time. So we see like there is problems with monoliths and benefits. So it's faster to like develop, easier to reach to the market, and everything is related to the speed is great, consistency and so on. But problems, it's a little bit hard to scale. Everything would be under a single bundle. It would take, and we said like with Webpack we could divide it. And another problem would be a huge amount of CI/CD pipeline. It would take a lot of like a long time to run in this case. And longer time of development means companies losing money. So because like developers are the most expensive part inside the company. With microservices, it's a little bit of the opposite. It's easier to scale. Each team would have their small pipeline. So instead of like taking hours or like many minutes, it would take like few minutes in this case, easier to develop. But problem with this one is inconsistency. Dependencies would take a long amount of time, and it would be hard for teams to onboard. So this is a problem statement. So most teams or most developers or most companies would use like either monoliths or microservices, but there should be a middle ground, and this middle ground that we would like to discuss, the monorepo. So the monorepo is trying to get like the good thing from monoliths and the good things from microservices. So the idea of a monorepo, you could think about it, it's like having a monolith, like monoliths from the outside, it's a monolith supposedly, but it has a like all microservices under it. So we'd have like microservice 1, microservice 2, and so on. Each one would be under this like monolith application. So you would say, okay, it's a little bit like monorepo, but instead of having like my application under source and then modules, I would have like modules at the top. It's not only this part. Monorepo would have 4 characteristics that would define a monorepo. So the first one, everything, all microservices would be under a single directory. So we would call this one maybe like packages. So this is the first part. The second part, each one of these packages need to be one of 3 types. The first type, it's either an application, like it's a small part of the application, like the one we mentioned in microservices, which would be reports or like invoices or any PDF or whatever one of these. Second type, it could be, let me write this one. So the first type, it either would be an app. The second type, it could be a library. And what we mean by library, so maybe like it's the UI component. So this is a library that's shareable either inside or even outside. Maybe it's the API server, maybe it's an SDK that is communicating between the like different applications and so on. And third part would be tools. Tools would be our description of like TS rules or not TS rules, like TS config, ESLint, Prettier, Webpack configs. Different configurations that inside the application, or maybe like scripts that build the application, shell script, bash script, or maybe like hooks that is used during like get commits and so on. So all of this would be under tools. So package could be one of these types. So this is the second characteristic. Third one, and this is the most important one, is that one microservice, when I change it or do any change to this one, it should only run or execute the CI/CD pipeline only for this microservice, not any one of the others. And this is important. And this is where tools come in. And Monorepo, like the biggest challenge about Monorepo is tooling. So it requires heavy investment in tooling, because you would need, okay, we will need like tooling to build maybe like our Python application, but it needs to be built with Python 2, not Python 3, or it needs like our Node.js maybe needs to compile first before the Go application is built. So it requires heavy customization in this case. So it requires investment in tooling, but the whole idea with investment in tooling, it increases productivity eventually. So instead of developer like pushing a comment and waiting like 1 hour for everything to be done, it would take like 2 or 3 minutes, because it's only building the single application. And in this case, they push it, everything runs, yeah, it's great, but please review, and everyone reviews it, give it some like comments, and then the whole cycle is a little bit faster. Not a little bit, it's quite impressive, like when you start developing this one. So this is the second important part. Third important part, which is like each one of them need to be run separately away from the other Microsoft. And third one would be each one of these microservices or different repositories, there should be a way to manage ownership. So I would say this microservice need like team A, for example, or this one needs like team B, and so on. Sorry about this part. Yeah, like this one needs team B, and so on. So each one would need like different teams, different management. Maybe the tools that have the configs need to be only managed by DevOps, and so on. And GitLab and GitLab and GitHub, like they have ways to manage this part. And of course, you could build custom toolings eventually to manage all this ownership. So it needs, like, the characteristics of a monorepo, it requires these 4 types. Maybe we could go to a new page. So the first one would be packages, and these packages could be either an app, or it could be a library, or it could be a tool. And this is the first this is the first part. Everything is under packages. Second part, each package should be one of these types. Third one, each only CI/CD pipeline runs for single repo or single package, like depending on the changes that happens to each one. And of course, this package and their siblings, because maybe package 1 depends on package 2 and 5. So in this case, when I change package 5, like maybe I draw it, so package 1 is depending on package 3 and package 5, and there is package 2, for example. When I change package 5, in this case, I should run also test and CI/CD for package 1, not only package 5. So this is also the third part. And the fourth part is ownership. This is what defines what is a monorepo at the end. So these are characteristics. Whatever the tool you are going to use, it doesn't matter. You could use actually like normal bash scripts, or you could use like maybe different YAML configurations and so on. So all of these you could manage with different tools, but the tools they just exist at the moment that would help you. For example, one of the tools that exist, this is Lerna that we mentioned, but there is another tool called Nx. And this is a tool that manages also monorepo. There is another tool that exists called Bazel, and this also by Google, and it also manages monorepo. There is another tool called Turbo Repo. This is also another tool that manages monorepo. So all of these tools exist, but it doesn't matter which one you would use. Eventually, the concepts are the similar. They would have these 4 things. They also define packages. They would have a way to define which type and what is the dependencies between them. There is a way to only run the CI/CD for only a single one using the changed command, and there is a way of ownership to define. Of course, like ownership is not defined inside these tools. Some of them may be defined, but ownership in general, this is also like the first type. So this is the whole concept behind monorepo. And we will start now by using Lerna to build our monorepo and transfer our application from its microservices, because usually when you start an application, it will start with monoliths, and then it becomes microservices, and then it would become a monorepo. Usually this is the transition. Sometimes it would jump from monoliths directly to from monoliths to monorepo directly, because the application is quite huge, and the investment from monorepo to microservice doesn't make sense to like separate them, each one in a separate repo, and then combine them. So I will paste everything inside this repo, and we will discuss it now. Now I have copied our sample application, and our sample application consists of 5 small applications. So the first one is our main app. Usually it would be called inside your company the shell, and it would encompass everything inside the application. And under this one, we have our cart. So this is basically like a store or checkout application. Of course, like I put like some dummy code inside it using basic JavaScript. So it doesn't rely on any framework, React, Vue, Angular, Svelte, whatever framework you would like to use, or whatever framework would come tomorrow. doesn't depend on this one. So we have our app, we have our cart, we have like a checkout page, and we have our UI libraries that consist of like different components that are being reused inside the cart and checkout page. So we have like the button, header, and so on. Header is also like used inside the app because this is like the whole shell part. And we have also utils, which are like different tools that are being used. For example, this is a tool to do like formatting to show website title or copyright. Maybe it's, of course, like all of these are concepts, but inside your application would be a little bit similar as well. So it would encompass like different packages at the end. And in each one of these applications, so for example, if we go to our app, you will see if we go to the index, we are calling at Monorepo Lerna card. So this would be usually inside companies which have like microservice application. It would be, each one of these would be a different package or an npm package that they publish to a repo. If it's a monolith application, instead of just like calling the package name, like getting the card page from the package name, it would be like using this one, like it's just going up and then going to the card and then going to source and then going to index, just to give you like the idea itself. It just different path naming or different way. So if it's a monorepo, if it's a microservice, it would be called this way. If it's a monolith application, it would be this way, just a different way. Okay, so first thing first, let's start by installing our monorepo, and whatever this tool is, it's still the same concept, but in this video we'll discuss Lerna. So first thing first, it requires installation. So first let's install it. And what we have done, the first step is we got every application or every repository, like the app, cart, checkout, like we did now. Everything is in a single place. So this is does the first part, which is we need to do like the packages. So we got everything under single place. So let's first move each one of them under packages. It doesn't matter. You could call them whatever you would like modules or whatever. Okay, let me grab this one and put everything under packages. So this is the first part. Everything now we got under packages. Second part, we needed, of course, like npm init. So let's start our application, and it says you would like this name. I would say yes, 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 yes. Yeah, whatever, all of this. But one thing, yeah, it doesn't matter. Yeah. So this is a part, we would call it like monorepo with Lerna. We could call it like monorepo Lerna, but yeah, it doesn't matter. So this is the first part. Second part, we need to install Lerna. So npm install Lerna. So this is the second part. So now we have, or after this one should install, or while it installs, it will install everything. Each one of these monorepo tools would have a way to configure them, to say where is the packages folder, like the things that we described at Zoom. They also could describe different parts, like which is the application, which is the library, which is the tool. Lerna doesn't define this one. Other tool like NX, you could be able to define this one. It's just like a way to definition to define it to the tool, and also it helps the tool to optimize, basically, like a way to optimize this one. So like in every part of this series, we also go to the documentation and we try to find like way of how to install this one. So for getting started, it says like nx lerna init, and this is the way to start initializing the configuration. So I would say nx lerna init, and it would create basically lerna.json, and lerna.json would have a way to define like where is the packages basically, or different packages in my application, and it would be under this packages directly. This is the first part. Second part, for each monorepo tool, there is a way of versioning. So there are two ways to do versioning for monorepo tools. The first way is that each tool would have the same version. The other way is to have each package would have their own version. Like app would have like version 1.2, cart 2, version 2, for example, and so on. The tools that have like everything have the same version and it uses Lerna is Babel. And of course, I think you would have heard about Babel. Maybe I would go to their GitHub repo because it would help you to see inside this one. So I would open this one. Yep. So this would be the monorepo for Babel, and it uses the single versioning one. Of course, this is a little bit now, it's new now to see like the Lerna stuff, but if you go to version 6, you would see actually the old Lerna file, and you would see it, they have the same definitions. So there is a way to define like packages, and you would see the whole like versioning stuff basically. So this one would be the versioning part. I think they might like have a different internal way to define packages, but we are only speaking about the versioning part. So they have like a single version, and they upgrade basically like all packages at the same time. If you don't need to use the whole version like a single version, there is other ways to define different versions for each one. But in this video, we'll only speak about single version. So let's change this one to version 1. This is the first part. Second part, we need to define different tools or executions that would run on our repo, because the whole idea of using a monorepo tool is that they have the tooling that we need. So one of the tools that would have, or one of the most important part, is a way to run a command over the whole application. And this would be Lerna exec. So maybe we could start by saying, okay, we would like to run the build command in each one of these repository. So we would define it at the outer part, or the outer package of JSON would say, okay, build, and it would be Lerna exec, and it would be, okay, maybe I don't get it on top of my head. Let's go to the documentation again, and let's go to Lerna exec, or I think it's Lerna run actually. Yeah, so we'd say Lerna run, and then we'll go to this one. Yep, it's Lerna run. So we'd say Lerna run, and then we'd say build. Okay, so this is the command that would run from each one of these. But this build command that we are going to run, we have to define it. So inside the app, if you go to packages.json, you would see the build command, and this build command eventually implements Webpack. You could think of this one as an interface. This is the idea that I like to get for this one. So if you would like to run a command like build command, you have to run, like you have to define the interface, this part, and then implement it inside each one of the packages. Similar, if you go to the cart, you would see another command to do the build. Similar to checkout, you would see another command to do the build. But without the whole monorepo idea, you would have to go to like each package, like cd, then run, cd, then run, cd, then run. But when we only define this one, like Lerna build at the top, and then say Lerna build, run build, in this case, we could run it all of them at once. So I was just npm run build, and this is at the top level, not from inside, this is at the top. And then I run npm run build, it should run each one of these types. Okay, it says like command not found. Why it says command not found? Because we haven't installed the packages for each one of the repositories that we have. Like inside checkout, there is Webpack, it needs Webpack, and so on. So we go to one of the important commands inside Lerna, and this would be bootstrap. So I would say bootstrap, it's a way to link packages. Okay, what we mean by a way of linking packages. So app depends on cart, and cart depends on components, and components depend on utils. So if you go to package.json and try to npm install, like if it's a microservice in this case, it would go to the repository, or not repository, like registry in this case, like the internal registry, and get this package and each one of them. So it wouldn't be the nicest way to get like all these packages to download and install them. But it would be better to link them. So in this case, if I change some file here inside the button, it would directly impact the other directly, which would be checkout. So this is the whole idea of linking. We try to link these packages together. So this is the first part. The second thing is that each one of these applications that we have, they have a like Webpack inside them. Like if we have like our normal application, you would see here you would have Webpack and then version like 5 and like whatever the versions that already exist. So you'd see like Webpack. But instead of having Webpack inside components, Webpack inside checkout, Webpack inside application, we could have a single Webpack at the top, and then we would be able to have node modules that contains all the packages at the top, and these small applications, app, cart, checkout, each one of them would be linked together. So this is the second part. So internal packages would be using linking or same linking in this case, like its name inside Linux basically. And packages that are common among all of them, we would add them at the top, which would be package.json the top level. But maybe you could ask, okay, how about like maybe app is using Webpack version 4 and components is using the newest one, like Webpack version 5. Yes, it would it wouldn't be actually a problem. This is one of the benefits of Monorepo, that each one of these packages, they have like a single CI/CD pipeline. Everything is unified, but we could still customize them. So I could still say, okay, no, this one still needs the older version of React. This one, yes, it's ready to be migrated to the new version of React. And from the outside, our Monorepo tool doesn't care about what is the library that we are using, what is the version, because eventually it would call build, or maybe it would call install from the outside. And in this case, it would run it for all of them. It wouldn't care about, okay, this is one using React, maybe I need like some custom stuff. Of course, like if you need custom stuff, in this case, it would be different. But the whole idea of the Monorepo is that it doesn't care from outside or inside. So let's start with installing our public tools. So this is the first part. So let's run npm install, and we need Webpack, and we need, of course, Webpack CLI to run this one. Yep, of course I needed to install them as dev dependency, but yeah, it's not a problem. Okay, so now we could try to run npm build again, but it would fail because it would say it doesn't know the packages from outside. Like the first one, it said like it doesn't know Webpack. The second one would say it doesn't know these packages. So we would run npm, not install, npm run build, and this would run the Lerna build command. And when we run this one, Webpack would say, okay, I don't know like what is this packages, like the different packages that we have, like where is the header, I don't find it, and so on. Like these things doesn't exist. So now comes the second command that we said, which is linking, and this linking is called bootstrap inside Lerna. So bootstrap, and we would say Lerna bootstrap. Maybe also I would show it here inside the documentation, and it would be this one, Lerna bootstrap. So let's take it, and we would run it here, Lerna bootstrap. Let's remove this one, and we would say, now let's run it and let's see what is the effect it would say. So npm run bootstrap. Okay, now we see node modules inside each one of the application. And when we go to this node modules, for example, for the app, we would see Monorepo Lerna, like the package that we were including, and inside it here we would see cart. And this cart is actually the same file for the cart that we have at the packages at the top. It's the same thing. It's just being sim-linked. This is some feature inside like different operating system, and you could look into this one. But basically, this is like a tunnel. You could think of it like a tunnel. And yeah, you would say like cart, it has like its own node modules as well being installed. Like everything is being installed as if each one of them is a separate application. And now when we run npm run build from the top, it would run the build command for each one of these packages. And now since each one of these packages have their own node modules, they are able to install. In our case, they are able to build. So let's run npm run build. Now when we run it, yeah, it says like the mode and so on. But yeah, you would see like each one of these packages run in a single command. This is the beauty about it. so I don't have to like do it multiple times, and you will start to see like the different dist folders for each one of our application, and our application is built. So this one combines everything. So this is the second part. Maybe we could also add the other command which does the cleaning, and usually cleaning is a little bit useful when you do like development for each one, because after we build the dist, you would like to go to delete each one of them. Yeah, it wouldn't be nice. So how about we have also another command called Lerna run clean, and clean is also implemented inside each one of them, and it basically like just like a command to remove the dist directory. So if I come back here and then npm run clean, yes, now we see each one of this folder is run. So it feels a little bit of like orchestra, or like you managing many stuff instead of having one hand. It's the same feeling when you have like multiple cursors, basically. Yeah, so this is the part that we described, where we have like packages. So we define each one of them. We have now apps and libraries, and of course like this one would be defined like in different tools like Nix and so on. Now the third part, and this is the most important part, which is CI/CD. For each one we need to define that changed, a single one. Okay, so this would be a command called if we go here, it would be def changed. Yeah, it's Lerna change. And basically Lerna change would say which packages would be changed. But if we run it now, so if I come here and then Lerna, maybe we add that change command and then we add this one. If we run it, pm npm run changed, you would see it says everything is changed. So you would say, okay, what is the way to define this is a change or this one is not change? What is the way to define this one? And the way to say like this is a version and second version, it's inside Lerna. It's a way inside Lerna, and it uses get commits tags. So it not get commit tags, it uses commit get commit tags basically. So when you are developing an application and you have done version 1, you would commit it, create merge request and merge it, and after you have merged it, you would tag it with version 1. And when you have like a new version, you would say, okay, this is version 2, version 3, and so on. So Lerna would start comparing version 2 with version 3, try to find the directories that have changed, and then would say, okay, this one and this one and this one have changed. So we have now a change, and this is like an application, like a difference, and we need to only do the commands on this one. Doing the command itself, it's a little bit different. Like it requires your custom tuning, but with it changed, like regarding Lerna, when you run Lerna change, it would say, okay, this directory and this directory from version, like the current commit you are in, from the last version, what is that change directories, and would give you back these directories. And after then you could use this to run your custom commands. Other tools like Nix, I think you could run the change command directly, and different tools as well, you could run it change directly. But with Lerna, so far I have found it. If you have found it inside the docs or there is a tool, please leave it inside the comment so we are able to change information about this one. But so far, you would using like Lerna change, you would get the repositories or the change directories. Okay, so we need to try to have like a way to publish it, to show it to you, like to show you like that change and so on. So the way to do it, or the natural way, we have to publish this one to npm registry, the ones that we know. But of course, we wouldn't use this one because this is like a public one, and we would need to use something to mock it, like something local. And there is a tool called Verdaccio, and this one is to mock registries. So basically, to create like a local registry. So this would be the tool Verdaccio. So this would be the tool that mocks the npm like locally and so on. and you would be able to install it. I wouldn't install it globally. I like usually, like when they say like global and so on, I like to install it inside the Git repo, because this case other developers would be able to use it as well. So I would just copy the name, this one, and I would say npm install, and this is save dev. Yeah, so it would now install our like library. This is the first part. Second part, we need to define like git init for this one. Of course, like internally it says like this is master because I have like different configuration, but we need to have like one internal, this one. So this is just like a separate repository. I have like a different configuration on my laptop. Okay. So now we have initialized our Git repository for this one. So we now have a repository, and we have installed Verdash. Maybe also we copy these tools just to be valid, and each one of them are under dev dependency. Okay. Now when we write git status, it's like everything change, and let's add our also git ignore, just also to not complain, git ignore. Yes, and we need to ignore node modules and our list. Let's git reset, I guess, and then git add. I will create like a video about these git commands. If you like it, just leave it in the comment as well. Okay, so now we see git status, we see like everything that we change, and now let's git commit them. So let's say first version, and now we have committed each one of them. So now our git should be clean. Okay, so this is the first part. Second part, we need to create like a tag, and instead of like creating this tag manually, Lerna have a command, or Lerna has a command. It's called Lerna publish, and this would do two things. It would create a tag and push these packages to a registry. You could define, okay, I don't want to do like push and registry and all of this. You could like customize it, whatever you would like. But at the moment, we would like to try publishing each one of these to a registry so other developers and other teams could use it as well. Or it could be published to a single pipeline to combine all of this, whatever the custom configurations that you would have inside your company. Of course, you don't need to publish, maybe just like doing the tag and so on should be enough. Okay, let's first start the registry and like our Verdaccio thing. Okay, and I could call this command registry serve. You could call it whatever you would like, and Verdaccio will just like need to start the command only. So I'll just like copy paste it. So this is our registry that we would like to start, and I would create a new terminal, a separate one, and then I would say npm run, and this our command. Okay, now it would start the registry, and I could open it. Let's copy and paste, copy pasta. And now we have our registry. It would say like different ways to install this one. So you might need to npm add registry, this one. So I would add it. I'm not sure if it would make a difference here because I already did this one. So if I add user, it would say what is the username. Let's say Abdu, and say password 1234. And what is the email? Yeah, let's add my email. And yeah, it would say like everything is logged in and each thing is defined. Okay, it didn't do much of a change. Okay, so this is the first part. Second part, we need to say to Lerna a way to know which registry to publish it, because if we don't define it, it would push to the like npm registry, which is the default one. So the second part would be to define the registry, and it would be this piece of code. Okay, if you would like to see this one, it's also inside the whole Lerna definition, like this one. You would see it here, like this one, the definition for it from the registry. Okay, so now we have the command and we have publish and we have the registry that we would like to publish it. And we have our application now have started, like not application, our registry have started. So now we need to publish them. So it would be the command to publish. So let's define this one and we would say this one would be called publish. So publish, and we would run Lerna publish, and I would just like add this one, like this piece of tag beside it. It's called no push. This is just because Lerna's default behavior is to push the code to like your repository or your registry in this case, to push it to your repository. But in my case, I don't want to push it because this is like a local development. If you would like to push it and see it inside your GitHub repository, you could just like remove the no push. I just like added it to not actually push to my GitHub account. Okay, so let's run npm run publish. Hopefully it would push all the packages over this show. It would say like, of course, like everything is not working because we need to build it. Okay, and it needs to like commit the changes as the current one. So let's say git commit, and let's say add publish command. Okay, I need to git add as well. Okay, so each thing is added. Yeah, because then let's say is like it prevents me from like publishing if there is uncommitted change. Like these tools also like have their behavior. You might don't like it, you could change it as well. So let's run the publish command again. Hopefully it would work at this time. So now start with saying, okay, what is the version you would like to do? So at the moment, the current version is version 1.0, like this one that we have defined. You could define it with whatever version you would like. Maybe you would start with 0.0.0 or alpha or whatever you would like. Okay, so you would say, okay, this is our major patch. We have added like a change from using like a monolith application, or at the current state was a microservice application, and we would like to move to monorepo, so it would be a major one. So it would say it's a major. It would say, okay, these are the packages that I'm going to change, and I'm going to upgrade them from this version to this version internally. And it would say, okay, this library is using private because I define it like inside the packages JSON, I just define it private. It's just to say, okay, I wouldn't push it to the registry. It would be only for internal use. Okay, so it would say, okay, are you sure you want to publish these packages? Yes, please. So let's see if it would push them. And it seems to success from the first run, which is weird. And it published them. Okay, I'm surprised it ran from the first time. Okay, so now we have all the packages have been pushed to learn like app and cart, and each one of them are like a package that could be reused. And we don't see our private package that we said it wouldn't push it. Okay, but without like jumping, let's go to the change. So if I run npm run change, it would say there is nothing to change, but let's go to our checkout and let's try to change this one. Let's add like, maybe I would like to add this one here, console.log new change. Like this is a new change for me. So now I would just like same, I need to add git commit, and let's add the commit change to checkout, and then I would run npm run changed, and it would tell me like what have changed now is the app, like from since the last change is the app. Or did I open the app? No, it's just checkout. Yep, it would make sense because what it changed, it's the checkout, and the app, this one at the top, depends on checkout. So in this case, it would say, okay, I need to run the commands for testing, linting, whatever, for the app and the checkout, but I wouldn't run it for the rest. Okay, how you would say, okay, I would run it for this too? You would need to write like custom tools. So you would take like this command and then send them to the other library like piping or using like bash scripts or whatever you would use, and then you would say, okay, I would like to run them for these two packages only. So this would be like the custom part on your side. But it would return to you like these packages, and now you know what have changed. And if I would like to run the publish again, it would only do the changes only for these two. So let's run our publish. It would say, okay, you would like to upgrade this one, because of course, like we are using like all of them normalized like versioning. It would push everything. So it would say, okay, you would like to update this too? Yes, I would like to push them. Okay, let's go back and see. Yes, we only see what have changed or have been upgraded with version is checkout and the app, but cart and components haven't been updated. They haven't changed because there is nothing happening to them. But if we go to Lerna.json, yep, you would only see like this one have been upgraded, because it says like this is a top version and the rest would have like the subsequent version. So these are the most important commands like for Lerna in general. So maybe let's recap them because we moved a little bit fast. So the first one is Lerna run, and Lerna run would run an npm command that is being implemented inside each package. So this is the concept of this one. There is another command called exec, and exec, it is executed as if it's from the terminal. So instead of writing like npm build, you have to run like exec npm run build, as if this is like inside brackets and so on. Like you could think of it like, of course you don't write it inside brackets, but with Lerna run, it's just like run the script directly. So this is the first one. Second one is bootstrapping, and bootstrapping is linking the packages between each other. So it would say this package depends on this package, and it does the linking between each one of them. And unchanged would find which library or which package have changed, and it would say, okay, this one changed, I would do stuff over it. And the fourth one, which is publish, and it would publish the change one depending on the tags from the previous like commit or push, like git commit in this case. It finds the previous tag and finds the difference, and in this case would say, okay, I would only publish these two. Okay, one last thing we haven't spoke about it, which is how the packages, they know each other. So there is one way to say with it's a dependency, and we would say, okay, this for example, like cart depends on components and it requires this version. But you might say, okay, I don't care about this current version, I need any version. In this case, you would just remove this version and add a star. And in this case, when you add this one, it would say whatever version here. It would take any version, like with just star stuff. And in this case, it wouldn't care. But you maybe, okay, I like for cart, I don't need this version. I maybe need like the older version. So I would run like 2.0 and so on. Like this is like the older version. And when I do npm install inside node module, it would install the old package, not with symlink, but actual installation. So it is the whole idea with this monorepo. It helps us to customize internally, but from the outside, everything is a single tool. And one of the helpful stuff we could add here, like a single ESLint file. We could have like a one prettier file and run it for all of them. And these tools like prettier, ESLint, TSLint, whatever linting or back tooling you would use, they usually have a way to extend them. So with extending, you could separate the common configuration and maybe special configuration for each one of these packages. So for example, you would say at the top package, you would say webpack. I would like to have webpack config for each one. But maybe for apps, I need to use a certain splitting algorithm or a certain optimization algorithm to do the splitting. So you would be able to still extend it and use the global configuration, but because we are implementing the build internally, depending on each package, you would only use the configuration you would like. You would use, okay, I would use the global one, but I need to change maybe the entry or maybe the output, or maybe because here I'm using a different loader. For example, you would use maybe app is built with using Vue, and cart is built with using React. If you have a monolith application, you would have inside the package.json, you would have view loader and you would have React loader, or like RxJS, not RxJS, sorry, JSX. You would have everything, like all the loaders at the top, and you would have like a huge web pack. But because this idea of Monorepo, we could have specific configuration for the app and we would only use view loader, and for cart, because it only uses React, we would have only the React loader. So this is the whole idea, that we start like separating. Of course, like it's not React loader. I think it's only using GSX loader from Babel and so on, away from all of this. So the main concept is still valid, is that we could specify different loaders for each one of these packages depending on the usage. So this is the whole idea, is to extend them and specify for each one of them, but still the global configuration is still the same. And one good thing about this configuration is that we know, okay, a team A or team B did a change, it's still visible for all the team. Or if I would like to change the package for the UI library, each one would be able to see it. So it also have better communication among team. Yep. So yeah, we could spend more time with Monorepo, but this is just like we said, this is a just enough episode, and it would cover the most basic stuff that you would need. Not basic even, like I think this is like intermediate. It would cover most of the stuff you would need from Monorepo. Of course, like if you have any questions, ideas, thoughts, things you would like to share or discuss with everyone, you could leave them inside the comment. And yeah, I think we could have like a wonderful discussion about this one. I think also like Monorepo is a huge improvement for your productivity. Yeah, I think this would be all we could discuss for this episode. Of course, like don't forget to like and share, subscribe, because it helps with the algorithm. And yeah, see you in the next episode. Ciao.